Encilia farinosa, the brittlebrush, is a staple of Southern California's dry and desert ecosystems. A close relative of sunflowers, its large blooms provide ample pollen and nectar to countless species of insects in places where these resources are scarce. Look at those bright, sunny petals. But wait, let's look closer. 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 Hold on, are those little things also petals? That's right, the flowers of the brittlebrush are really organized clusters of dozens of flowers. This is the signature of the sunflower or daisy family, Asteraceae. With some very rare exceptions, every member of this family has its flowers arranged in what's called a compound head or capitulum. The family has direct benefits for humans. Sunflowers, lettuce, and way more ornamental plants than you might realize are in this family. The family is also enormously environmentally important. Its members are host to just about every kind of insect you can think of, and just about anywhere you look, you can find some members of the family that are invasive. But it's also, according to the current estimates, the largest plant family in the world with a huge diversity of forms and variations. This, combined with a number of highly specialized parts, can make identification a real chore. And that's why I'm making this video. In this video, I'll introduce the family and its general features and discuss the radiate head type, more details to follow, with more videos to follow on variations within the family. Before we look at this family specifically, let's go over some basic botanical terms. There are pretty good videos and other resources that cover this elsewhere, so I'll be as brief as I can. A flower consists of multiple concentric whorls of modified leaves, each of which serve a different purpose. The outermost whorl is called the calyx, and the calyx consists of parts called sepals. So there's a sepal, and together they form the calyx. And from there, we've got petals. And the petals together form a whorl called a corolla. Now, and from there, we have the stamens. These are the male parts of the flower. They produce and release pollen. And then in the very center, stamen. And in the very center, we have a pistil, which is the female part of the flower, and it will eventually develop into a fruit. Now, the stamen consists of a stalk called a filament and a head of pollen sacs called an anther. And then a pistil consists of an ovary, a stalk called a style, and somewhere along the style or at the tip of the style is an area called the stigma, which is where the pollen needs to land in order to fertilize the ovary. Now, these whorls can either be totally free with separate petals and separate sepals, or they can be fused together. So you can have a calyx consist of like 5 fused sepals, for example, and these whorls can also be fused to each other. So you can sometimes have a stamen that's fused to a corolla, for example. Another thing to mention is that family has a specific meaning when it comes to putting organisms into categories. Families are between an order and a genus in rank, and below the genus are the species. A single order can have multiple families. A single family can have multiple genera, which is the plural of genus, and a genus can have multiple species. Generally, the family level in plants is the most easily distinguishable rank, as the features that help define them are usually pretty easy to observe. In the family Asteraceae, the main feature is that sets its members apart from almost all other species is that the flowers are clustered into a compound head, and that compound head is protected by one or more whorls of modified leaves called filaries. Now let's go out and find an example. All right, here we have a cousin of the brittlebrush. This is Encilia californica, the bush sunflower. And you can see right here on the outside of one of these spent heads right here, you've got those filaries which protect the flowers on the inside. Again, you can see those filaries. The filaries collectively are called the involucre. And this is a radiate head, one of many variations of heads in the sunflower family. The radiate head is what I'll be discussing today because it has the full suite of features I want to talk about. Right here, these long yellow things, these are called ray florets. And in the center there, where you can see the little yellow styles poking out, those are the disc florets. Hey, this is Future Justin here, just chiming in to say, explain what a radiate head is exactly. A radiate head is a head which consists of both the ray florets and the disc florets. If you've got both a ray floret and a disc floret, it is a radiate head. Those are the disc florets. And they've got brown corollas here in this species, but the brittle brush usually has like a more sunny orange center. I'm gonna grab one of these to take into a look under the microscope really soon, but first I also want to mention, you can see like the darker green leaves is what really makes this stand out as a different species from brittlebrush, but there are other differences too. Here's another species in the family with a radiate head. This is Heterotheca grandiflora, also called telegraph weed. It got that name because you'd often find it growing along the railroad tracks and the telegraph lines, because the railroad company or the railroad cars would often trail the fruits of this plant along with them. So the filaries on here look kind of different, and they have like they have like somewhat messy ray florets, and the disc florets here are more yellow in color. But yeah, still a radiate head, still has all the features that you'd expect from a radiate head. Heterotheca grandiflora, the telegraph weed. All right, so now we're back inside, and we've got the head, got all those filaries, the rays, the disc. We're gonna cut it open. All right, here it is in cross section. So once again, you can see that the filaries, they actually are in multiple rows. You can see that. There's a row, there's a row, there's another row. Each one of those rows is also called a series. So an involucre, remember that's the term for the collectively all the filaries in the head. This would be a kind of involucre called a multiseriate involucre. You can see 1 series, 2 series, 3 series, multiseriate. If an involucre only has 1 series, 1 row of filaries, that would be a uniseriate involucre, and ragweeds are often a nice example of that. Sometimes they have little vestigial filaries towards the bottom that don't really do much. All right. So here we go again. Here's a disc floret. Oh, I just pulled the disc, or not a disc floret, the ray floret. I just pulled one of the ray corollas off. And then here in the middle, those are all the disc florets. Okay, here we have a close-up of the disc in cross section. You can see all the little disc florets. Actually, here you can clearly see each one of these things is its own flower. Let me focus that. So there, you can even see the petals on there. And let's just grab one of these and pull it out so that we can take an even better look of it on its own. Okay. right there. All right, I'm gonna put another one of these in here for some clarity. All right, so this one, it hasn't opened yet, but oh, there's a little thrip on there. Just another example of the wide variety of insects that these species can support. Sorry, thrip. All right, so this thing right here, which is not present in all members of the family, this thing is a little modified leaf called a palea. And paleas can add some additional protection for the flowers in the inside of a head. They can also help serve a function with seed dispersal, depending on the species. So let's take this out of the palea so you can see what's going on here. Whoop. There you go. Now in Celia californica, the fruits are actually the fruits in the ovaries, which the ovaries turn into the fruit, are quite hairy. You can see that there. Now, what you can't really see very easily is that there are two distinct things poking up right here. These like kind of tattered scales right here. These are, this one and this one, these are a signature of sunflowers and their relatives. And this is what's called a pappus. Now, most members of the sunflower family have a pappus, but most of the time it'll be these long plumes like you see in dandelions, for instance, which are also in the family, which help with air dispersal. In the tribe Helianthii, which is the sunflower tribe, you get these two scales, one scale, two scales that come off the side. Sometimes they're more like bristles, and sometimes they're completely absent, like in your typical sunflower seed fruits. But yeah, this is the pappus, and what it basically is a calyx. What you can see here, these are the petals, which are fused together in a tube, but there's no calyx. Where's the calyx? It's the pappus. It's been turned into this thing called the pappus. All right, now let's go take a look at our opened flower so you can get a better look. It too is sheathed in the palea right now, so I'll just take the palea. Take the palea off. And there you go. Let's see if I can get it autofocus. No. All right. So right here, you can see one of the corolla lobes. And a corolla lobe is just a piece of the petal that has separated from a corolla tube. And from that, you can see there's 1, 2, 3, and on the other side, there are 2 more. So there are a total of 5 petals in this corolla. Most members of the sunflower family have 5 petals. Some have only 4. All right, right here are the styles. And on the inner surface of these styles, that's the stigmatic surface, the stigma. So I'm touching the stigma right here. If I touched on the other side, I'm no longer touching the stigma. So 2 styles and a stigmatic surface on the inside. That is very typical of the sunflower family Asteraceae. And then right here, these purple bits that are poking up right here, these are anthers. In the family Asteraceae, the anthers are actually kind of, I'm not sure if they're entirely fused or just pressed together into a tube, but the anthers form this tube. And what happens when a flower opens up is what first will happen is that these styles are pressed together. So the stigmatic surface is completely hidden from them pressing together. And then it'll push up, gathering pollen along the way, and poke out. At this point, these 2 are still pressed together, but on the outer surface, it'll be covered in pollen, and it will actually present the pollen to pollinators. The pollinators will pick up the pollen, and then later, these 2 guys will spread apart revealing the stigmatic surface and making it receptive to pollen. This is an adaptation that prevents these guys from pollinating themselves, because fertilizing yourself is like the ultimate form of inbreeding, and bad things happen when you get too inbred. So this is a way that they use to prevent inbreeding. If I scroll further down here, you can see the tube narrows, and then you hit this ovary right here. Now you can see that this actually does have the shape of a sunflower seed, which really goes to show how closely related these guys are to the sunflowers that you can buy in the store. So this is an ovary. It'll later develop into a type of fruit called an anakin, or some people refer specifically to the fruits in this family as a sepsilla, or with a plural, sepsillae. And so this ovary will develop into that fruit. And once again, here are the two pappus scales. Now the ovary is in a weird position compared to the example I showed you earlier of a typical flower, because this ovary is actually below the petals and the sepals. This type of ovary is called an inferior ovary. It's not a judgment. These are no better or worse than other ovaries. It's just inferior in this case specifically refers to the fact that it is below, inferior to, the corolla. Every member of the family Asteraceae has an inferior ovary. All right, here we have one of the ray florets. Now the ray floret looks very different, and the reason for this is that in the genus Encilia, and in fact, most if not all of the members of the Helianthae tribe have sterile ray florets. Right there's the little puny excuse of an ovary right there. It's very underdeveloped. And so it puts all of its juice, so to speak, into making this massive corolla. On the back here, you can see that here's a 1 vein, 2 veins, 3 veins. Those are three of the 5, 1, 2, 3 of the 5 petals that make up this corolla. And then over here, there's a smaller one right here. Here's 4, and over here, there's 5. In most members of the sunflower family, the rays will only the center 3 will extend all the way to the tip. So you'll often have at the tip here. Let's see if I can find a better example. At the tip here, you'll usually see 3 little nubs at the tip. 1, 2, 3. In members of the dandelion tribe, or the dandelion trickery tribe, you'll actually have the petals will actually extend all the way to the tip on the other 2 as well, so you get 5 little teeth at the tip. All right, here we have the Heterotheca grandiflora, the telegraph weed. And look at the phyllaries on the outside. The ray florets have begun to curl up because it's starting to wilt. And if we flip that over, I've already cut this open. You can see right here the disc flowers, the individual flowers that are attached right here to what is called the receptacle. So the florets are plugged into that receptacle until they ripen into fruits and are ready to disperse. Also, take a look at these nice, look at them. These nice glandular trichomes on there. The smell that these little things produce is quite strong, and I find it quite good. It kind of smells like oregano to me. So if you ever see one of these guys in the wild, get your fingers on them and then sniff your fingers. It smells really nice. So, let's take this guy apart. I'll first admire those phyllaries right there. So this guy also has multiseriate phyllaries. It's in the tribe Asteraceae, the aster tribe. And the filaries definitely look like members of that tribe with the little purple tips. A lot of fleabanes, for instance, have those little purple tips to the filaries. All right, here it is cut open. You can see again on the outside we've got the filaries. Those guys protect the flowers in the middle of the head, and on the inside we have ray and disc florets. So here I'm going to grab a disc floret and a ray floret to show you. All right, here we are looking at a ray floret on the left, right here. That's the ray floret, or sorry, disc floret, and a ray floret on the right here. And unlike the bush sunflower, the ray florets are actually fertile. So you see they actually do have a well-developed ovary. But noticeably, you'll see that on this species of Heterotheca, you have much smaller hairs. It's much less hairy than the disc ovary. So ray ovary, disc ovary. And also you'll notice that the ray floret actually does not have pappus, whereas this guy actually has a pappus, and you see the pappus is made of these bristles, these long slender bristles. And if you look even closer, you might see that they're a little bit, aren't they barbed in this one? Yeah, you can see the barbs on there. So yeah, a little tiny barbed bristles. And these bristles function much the same way as the pappus of dandelion flowers. These will, when the fruit is ripe and ready, these bristles will spread apart into an umbrella shape and carry the seed off with it. Moving up, so we have the ovary down here. There's the pappus, which is, as you remember, a modified calyx. And then the corolla tube is kind of hidden behind the pappus right here. And towards the tip, you got the corolla. So you can see the 1, 2, 3, 4, 5 corolla lobes. And right here, you've got your 2 styles poking up right there. Just the same as in the bush sunflower. And then we move over here, over to the ray floret. You can see it's begun to curl up because it's been out of its flower too long. It's starting to wilt. But there is that nice long corolla of the ray floret. And again, in this one, you can actually see you can see those, the stigmas, the styles and stigmas poking out right there.